right? So when it comes to finding the actual length, it's 2 times 1 divided by that. So it's 2 divided by 0.005. And if you grab your calculator, right, 2 divided by 0.005, you get 400. What do you think my units are going to be in? 400 what? Yeah, right, you started with centimeters. Your resulting answer is also in centimeters. Okay. So what would that be in meters? If you divide that by 100, right, you can, or actually let's do it the proper way. 1 meter has 100 centimeters. So if they asked you to figure out what it is in meters, it's 4 meters, right? I don't know if the textbook probably did it in meters. I'm guessing. Sorry, you can't see that there. But that would be now the length of the actual room, bedroom number 2, that is. And then you repeat the steps for the width, right? So you start 0.05 is equal to the to 2 centimeters, and you're going to find the width of the actual room. And because it's the same, it's 2 centimeters again, what's your answer going to be? It's going to be 4 again, right? But if you remember, the 1 here is very powerful. It tells you, oh, I have to multiply and therefore divide by 0.005. So the width is 2 times 1 divided by 0.005, which is 400 centimeters, which is 4 meters. So now you found the actual dimensions of the bedroom. In meters and centimeters, they didn't specify. Both would be acceptable, both answers. So always remember, this is what I want you to take from this. That this up here, this formula is going to be used over and over. In everything we do, basically, I refer back to this fact here. Okay? And you're like, Mr. Dixon, why am I not using new and original? Because you're not making, like, I have a diagram and I have the actual room. I prefer to use diagram and actual when there is a picture or a diagram of something, right? You will see down the road that we'll be making copies of something. I'll make a copy of the original, making it larger or smaller. Then I use new and original instead. It asks you to draw a scale diagram down here. I will show you how to draw a scale diagram, but it will usually not be as complicated as this one. It will be fairly straightforward. There might be maybe a bonus question where you have to draw like a scale diagram of something more complex, but I'll do that in my notes as well. And I think I'll just leave it at that for now, and then today after my lesson, I'm fairly certain that you'll be able to do more of these questions here. Okay. So let's go back to page 11 in our notes here, because I didn't finish that question. So we were given 2 similar shapes, and in math, when we say similar, it's not just they kind of are like each other. When we say similar in math, it means that everything has been affected by the same amount, every dimension, right? So we went from diagram to actual. So the scale we figured out, we were allowed to use different units. The scale factor, however, we basically used our answer here, stacked it as a fraction, then did some conversion, right? Did a conversion here to get everything in inches so that it would cancel out, and then we get our fraction without any units attached to it. That's very important. I think I told you that I was going to show you a cool feature about this calculator. So if you have this out, I just have to quickly review how that works. Okay, just give me 1 second. Math. Yeah, there we go. So remember simplifying fractions? It was a bit of a pain, wasn't it? Every once in a while. So in applied, we don't worry about that too much. Like if you gave me that answer, I'd be fine. But from time to time, I ask you to reduce your fraction. And so what you do, not always, it doesn't always work because sometimes it just can't. It means you can't reduce it any further. But if you were to go 14 divided by 300, don't hit enter just yet. Then you go press math. Press the math button once you've got 14 divided by 300. And the first option is fraction. Right? It's the very first option. Just hit enter. And then enter again. And there is your simplified fraction. It's 7 over 150. Which is basically they just divided both of them by 2, right? Like if you were to divide both of these numbers by 2, you get 7 over 150. But it's not always that obvious. So I will just do this in your notes. Right? If you press math and then press 1, you get 7 over 150. It's a reduced. Okay. So that's just an aside there. If you ever need to reduce, then that's in grade 12 applied. You will use this more, this feature. So there it is. See? Now we're going to step it up a notch. Okay. So determine the height of the truck on the diagram. I want you to know something very important, that everything is connected that we're doing in this unit. And I will try to make you see those connections. So determine the height of the truck on the diagram. So they want to know this, right? Let's call this X here. Okay. Up there on we want to know the height of the diagram. You have options here. You could use this, or you could use, I prefer, you can technically use any one of these 3 here. I prefer the fraction, because when you're giving me decimals, you're rounding. So so you can pick either this or this to answer the question. I will pick my scale factor. I will say this, that K is equal to the height in my diagram divided by the height of the actual truck. That is ultimately how you got your scale factor, by doing that. Except for we didn't compare the heights, we compared the length of the truck because we had both lengths. Right? So this here, I will replace it. In this case, my scale factor is a fraction, which is kind of nice. So I'm going to use 14 over 300. And I'm going to use, this highlighter doesn't really work. Where's my pink one? Oh, here. So I'm just going to tell you that, right? I'm using that. I hope you can see it. Oops. 14 divided by 300. Kind of ruined it a little bit. I apologize for that. The height of the diagram is unknown to me, but I have the height of the actual truck, which is 10 feet right here. So I just plug that in there. Sometimes you have to convert, sometimes you don't have to. And then we just, in this case, we go over to our variable, that side, we start with a number, so we have to multiply up, divide down to get our answer. So it's 10 times 14 divided by 300. And that is 0.466. It keeps going. And what is our answer in? What did we start with in this equation? Feet. So our answer is in feet. Got it? What would we prefer? In this case, what would make more sense to state it in inches, right? Because you can tell that the length is 14, right? You can tell that this is 14, it's in inches, so we would like this in inches as well. And hey, didn't we learn how to convert? Yes, we did. So I'm going to quickly, before I clear this on my screen, I'm just going to do a conversion here and then state my final answer in inches. So you keep that there. I basically just multiply this answer by 12 and I get 5.6. That's better. 5.6 inches is my answer. That is the height of the diagram. Okay. So I need you to know that to go from from the actual to the diagram, what happened, right? K is 14 over 300, right? We multiplied the actual by the scale factor to get this over here, okay? That's actually what happened. We found that constant that would get me from one side to the other, okay? So whenever you find a scale factor, you're finding how has the actual been affected to get the diagram. Obviously, it's a reduction, right? How else could we have predicted that without looking at the diagram? Remember, you're looking at K. If K is less than 1 or less than 100%, it's a reduction, right? Do you remember that? Yeah? Okay, so everything is connected. That's what I'm trying to get you to see here with this example. All right, let's move on. I want you to try this one based on what we just did. Okay, I want you to try this one. If you make a mistake, big deal. We're going to erase, and I'm going to go over this anyways. But for now, you give this a try. See if you can wrap your head around what we just did. I think I'll take it back. So we've got that the diameter of the animal cells represented by this scale diagram and is actually, right, the actual diameter. So we're talking diameter first of all, and we know the actual diameter is that, right? And so this over here is a diagram, right? So we actually can, and why that is important is because we need to know, right, where's the actual, what's the diagram, what happened here. So we can tell that what happened to the actual to get to the diagram, there was an increase, right? There was a zoom in. So we're expecting our scale factor to be greater than 1 or greater than 100%, right? So for A, the scale used, we're going to go diagram, actual, okay? And what specifically is diameter, right? Diameter of actual diameter, those are the only two dimensions we have. So we go diagram is 4.75 centimeters, and the actual is 0.25 millimeters. So it's okay to have different units, but we don't like the decimals there. So what are we going to multiply both sides by? 100, yeah. So you can kind of just go like this and go times 100. And then it's 475 centimeters to 25 millimeters. And sometimes I convert right away, other times I don't. Okay, so it depends on, it really doesn't matter to me. Okay. If I tell you reduce, then you'd have to reduce. So just keep that in mind. Technically, this is correct, but to get the full marks, you still need to get rid of decimals. Okay. So B, state the scale factor. So there I basically just turn this, right? I go 475 centimeters over 25 millimeters. That's the first step. And I don't like the different units when it comes to scale factors. So I convert. I will convert the greater unit to the smaller unit. That's usually how I do it, okay? So I'm just going to go on the side here. 475 centimeters times 1 centimeter has 10 millimeters. Cancel that out. So it's 4,750 millimeters. Okay. So that's a conversion I made on the side. I bring it back here, 4,750. I'm okay if you do that just like that without showing the work, especially when it's just simple calculations like that. We get to cancel out the millimeters, and essentially I'm done. Okay, I'm going to try this, 4,750 divided by 25. Let's see if it's a whole number. Maybe it is a whole number right off the bat. It is, so I don't need to even bother simplifying it. Right? It is just 190. Okay. This would be all right with me. 190 is preferred, right? So that is my answer. What would that be as a percentage? You can still state it as a percentage, right? So 190 times 100 is 19,000%. So it's still doable. Just multiply something by 100 and you get the percentage there. So C, is this an enlargement or reduction? So there I'm just testing to see it's an enlargement, right? Since K is greater than 1. You can write it in words or you can use symbols like that. Use the proper notation, I'm fine. 190 is quite a bit bigger than 1, right? So it's actually quite a bit of a zoom in there. D, so that's usually what I do. Once you have your scale factor, I can ask you anything, and you can go back and forth between the diagram and the actual. So if the nucleus has an actual diameter of 0.12 millimeters, right? Determine the diameter of the nucleus in the diagram. So start with this, folks. Diagram, actual, and then fill in. K is going to be replaced by 190. And then I'm given the actual, right? I'm given the actual. I'm going to highlight that in green, right? The actual diameter. So that goes here, 0.12 millimeters goes there. And so this is my unknown. I hope this is not going to ruin it right there. I think it's not too bad. And then you put the one under here anyways, right? Just to get you to see what do I need to do. Some students need that to help them out. So I cross multiply and divide. I'm not going to divide by 1 because it's not necessary, but this gives you 0.12 times 190. So that's 22.8 millimeters. If they wanted to find it in centimeters, right? Or we would just go 2.28 centimeters, right? Just divide that by 10 to get the, so there is your answer, right? So once you have this, once you have the 190, right? Once you have K, I could give you the actual, give me the diagram, or vice versa, right? You can just find anything like that. So scale factor is very important to find, and then you can do anything you want, okay? So here, this is textbook stuff. You should have seen this. Determine the scale factor used to create the new shape. So if it's original, I'm using that wording new, okay? So I'm actually going to go ahead and do that. And therefore, I'm going to use, you should have both on your study sheet just to remember where do they go. And this is a unitless scenario, and that's perfect, right? All you're going to do is you decide. I'm going to count, I'm going to find corresponding sides, right? I know that this side corresponds to that side. So here I have 1, 2, 3, 4, and over here it's just 2, right? So it's 4 over 2, which is just 2, or 200%. I'm going to go green here, right? That I used these two corresponding sides to get me that. Or, right, you should also be able to just use the other two corresponding sides, which is this side corresponds to that side, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay. So you go, uh-oh. You see that I made a mistake, right? Yeah. You can feel free to stop me. Anyways, it's new over original. That's the mistake. So it should be 2 over 4. And it's recorded, so I can't even pretend like I did make the mistake. 2 over 4, which is 1/2, which is 50%. But first, because it's a fraction, not a whole fraction, I actually can write it as a decimal and then percentage. So you can truly state it in the 3 formats. I apologize for that. So it's 3 over 6, which is still 1/2, which is still 0.5, and you get the picture. It doesn't matter which two you pick, you should be able to come up with the exact same scale factor. And that's when we say they're similar, when everything has been affected by the same amount, okay? And so the homework, if you were stuck with a few, it still applies to this section right here. Go ahead. Are we good with that? Does that make more sense? You think if you redo the homework, you'd be in better shape? Yeah. And it happens sometimes, okay? It will happen to you. I actually like that. Like if you're like, wait a minute, I can't, I'm stuck. And then when you come back the next day, you'll be looking for stuff and be like, now I know. That's what I needed to hear, okay? So it's almost, you're taking ownership of your learning. Let's try B. I'm going to give you a little bit of time to try this page 13. I want to clarify what's happening here. So this is still asking you to find the scale factor based on what you see. So if this is the original, what are we going to call this? New. Yes, you got it. If this had said actual, then I would say let's go with diagram, right? So keep it consistent. I want you to find the scale factor, right? So you're basically going to be like, what's the scale factor? That's your first order of business. And then you're going to find X and Y. So remember, you need to find two sides that correspond, that you know both sides of, right? To find your scale factor, and then you go from there to find the rest. So give that a try. Think it through. It's all connected, okay? So take some time. Some of you are like, I need more time. But I also know what I need to cover, so I'm trying to dance in between. Okay. All right, so in my quest for finding K, in this case, I will use new over original. Those are going to be, what I'm going to stick to. And in this case, I'm looking at my shape here, and I have these two sides that correspond to each other, and I actually know both of them, right? So I'm going to go 5 yards over 14 inches. So if you didn't do that right in the order, then just be careful, right? But that's the start. And I don't know, I always forget because I teach conversions in 2 courses, what I gave you, but 1 yard has 36 inches, correct? So I will just multiply by 36 real quick. I allow you to do that. That's 180, 36 inches, right? I told you, yeah. So that's 180 inches over 14 inches. And at that point, you can cancel. I see that they're both even, so chances are that you're going to be able to simplify that. Oh, it's 4. I did 4, not 14. My bad. Math 1. So it's 90 over 7. I could have done that in my head, right? But don't want to get this wrong. So that's my fraction. And because the question doesn't tell me stated in 3 formats, I'm just going to leave it like that, because I like to stay with the fraction. Unless you're going to use all decimals, then it's okay as well. So let's see here. If I want to solve for X first, okay, it's going to be my first order of business. I'm going to start with you can use either one, by the way, right? Either one. K is equal to new 3.5 yards over original. So that's how it's crucial to set it up right. If you use the decimal, right, that's okay. Is it 12 point something? I think it's 12 point something, right? That's okay. Just put a 1 under it, right? And use as many decimals as you can. Like, you just go back to your calculator, right? If you go 9 divided by 7, have that up there and just go as far up as you have to call it back, okay? To copy it. That's the beauty of these calculators. So anyways, you multiply and divide like that. So it's 3.5 times 7 over 90. Okay, so let me go back here. 3.5 times 7 divided by 90. Is that right? I think so. 0.2722, and I'm in yards. And we can tell that I'm finding the original here, so I would like that in inches. So I'm just going to say that 1 yard has 36 inches. It's just prettier, okay? It's not like it's wrong to state it like that, but there's a big chance that I will ask you to state it in inches, right? So it's 9.8 inches. Okay? So, right, I have that's taken care of, okay? And I have to find y as well. So y, I start with the same method as before. And then I just have to be careful. Take a break, right? Take a little, it's like, okay, wait a minute. New over original. Okay, and in this case, my answer will be inches, right? And that's okay. So you cross multiply and divide like this. See how x and y are not in the same spot. I did that on purpose, right? I want you to think. 11 times 90 divided by 7. So that's 90. So 11 times 90 divided by 7. That's 141.42 something inches. I'm going to say that 1 yard has 36 inches. Cancel out the inches. Sorry, you can't see that, can you? So I basically need to divide this by 36, and that's 3.93 yards. And I'm just going to highlight that in yellow. How's that? There you go. You can still see it. So, is that good? You get it? You're feeling it? It's all connected, right? Conversions, scale factors, right? Everything is connected. Yeah.
Do you want us to always
Simplify the scale factors? No, unless I will sometimes ask for it, but more often than not, it's just give me what it is. Don't care. Yeah. Tell me what it is. Don't care if it's a decimal percent, unless I specifically ask for a format. A can of pop has a height of 12 centimeters. Important, right? I'm gonna highlight that. So the actual can, correct? I don't have to say it. That's the actual height. A similar can has been made using a scale factor of 62%. How tall would it be? So whoa, right? So this is height of actual. Should I use new or original? You're making a copy. You're making a copy. Yeah, so I'm going to go height of original. This is my original can. A copy will be made. And so you want the height of the new is what they're asking. What's the height of the new can? So sometimes you'll have to decide. But if there's a picture, a map, or a diagram, I'm going diagram actual immediately. But if it's like making a copy, something similar, I'm using new and original. Got it? Okay. So scale factor is 62%. I don't like percent, so I'm going to go 62 over 100 or 0.62. Whatever works for you. Use the 62 over 100 or use the 0.62, but I'm not going to use percentages. Okay. So K is equal to the height of the new divided by height of original. Okay, so 0.62, I'll use a decimal, right? Height of the new is unknown, and the height of the original is 12 centimeters. You put the little 1 underneath, right? If that helps you, if you need it, if you don't need it, that's okay. Cross multiply and divide. I'm going to show you what I don't want to see. So technically you're dividing it by 1. So 12 times 0.62 is 7.44, and I'm in centimeters, so you stay in centimeters. So that's the height of the new can, which makes sense. It has been reduced to scale factors less than 1, right? Less than 100%. So the resulting, the new will be a reduction. All right. Soon we're going to see what happens to the areas and the volumes. Right? Scale factor affects the sides. It also affects how much pop fits into that can, right? And we'll see how that is affected. Okay. Convert the following using the following scales to scale factors. I will leave that to you. The answer is right there. If you want to have more practice on converting, there it is. Okay. So these are the answers in case you're wondering what's happening there. Let's keep going. I don't know if you have a ruler. Be great for the next section of scale diagrams to have one. And this is going to be it for today. Okay, so just make sure you write this down. Where's my ruler? Here. So 3 steps, as easy as 1, 2, 3, right? Convert actual dimensions using the scale. Draw object using conversions in one. Label diagram, watch this, using actual dimensions. Okay, that is important to remember. Okay. That is the one perhaps that most students get wrong because they're like, hey, I calculated my new dimensions, so I'm just gonna use those. But and this is different than the textbook. You're like, why aren't you consistent? Well, this is how they want us to teach it, right? So I guess provinces differ because this is also made for BC, right? This textbook. So the dimensions of a room would be length and width, right? As described there. Draw a scale diagram using this scale. So this is my scale. Okay. Not a scale factor, it's a scale. Could we turn it into a scale factor? Yeah, we could. But when it's scale diagrams, I keep it like that. I keep it like as is, okay? So convert actual dimensions using the scale. So we're going to go length. We're going to do the conversion here. So I'm going to go, watch this, 1 centimeter over 2.2 meters. So I'm taking my scale, I turn it into a fraction like that. Always remembering, hold it. When we're looking at a diagram, right? Scale diagrams. What's the first number? It goes with diagram. And the other one is actual. Always remember that never changes, okay? I don't have to tell you that, you should just know that, which means that where are we going to put the 12 meters? 2 things that give it away. The first thing is that this is the actual dimension, right? And the second is that it's in meters. So this is 12 meters right here. And let's call this length. Let's call that L. I don't want you to do this. Choo-choo trains, right? So proportion should not have another equal sign with the answer next to it, okay? So don't even try it, okay? So multiply, divide. So it's 12 times 1 divided by 2.2. And so it's basically 12 divided by 2.2. It's 5.45. What are we in? Look at your proportion. Meters match meters, right? Centimeters. Actually, I should have done that here in my notes. When you're matching units, when units are involved, you match them like this. And so this is in centimeters. And then for the width, same thing. We use a scale factor, not scale factor, sorry, the scale. Width in centimeters. And the 8.6 meters, which is the actual dimension of the room that I'm supposed to make the diagram for. So width is 8.6 times 1 divided by 2.2. 3.91 centimeters. Boom. So you've made your conversions. What does that mean now? I use these to determine how much space that's going to take up on my piece of paper. Okay. So if you have grids, you would use a grid paper. I don't have that. So you just go 5.45, you use your ruler. And I made sure this fits, so I'm going to go 5 right there, 4, 5, so it's about half, right? 545 centimeters. And it's 3.91 going up, so not quite 4, just under 4. You can just get it as close as possible. Okay. So then I close it. So this is a scale diagram of room. And this side will be 12 meters, and this side will be 8.6 meters. Okay. So you make the conversions to determine, so this is actually drawn to scale. If I were to increase this thing by the same amount, I get back to the actual dimensions, right? It's been decreased to this. So 3 steps. I encourage you to have that on your study sheet. There's going to be one question on the test drawing a scale diagram. And the presentation varies. It could be that I give you an actual, like, hey, this is a picture. These are the actual dimensions. Draw a scale diagram. Or I can just give you a sentence and go with it. Okay. 1 second. I'm just going to peek what's on the next page here. Yeah. So I actually wanted you to. You can go back to the homework if you need to. If you feel like you need another go at the homework, but the actual homework for today is found in your workbook. Did I give you workbooks? Yeah, I did. Okay, thank you. Trying to find mine. Yeah, it looks like this. Right? This is your workbook. And so just go to page 5 to 6. And it goes back a little bit to way at the beginning. So I kind of review some converting, figuring out the best purchase. Remember, guys, converting and proportional reasoning is connected. Scale factors are also connected, right? Everything is connected. Remember that. And so take some time to do the homework. Thank you. If I don't post the answer key, please just let me know. I forget sometimes. But pages 5 and 6 in the workbook